Today I'm going to tell you a story about heroes, lots of obstacles, and the holy grail of the test automation, the perfect system test design recipe. With a mix of personal and methodological stories, I'm going to present to you 8 criteria for system test design assessment. You can find some of them in different books and blog posts, but this list is unique. My teammates and I created it specifically for our system test design improvements. Today you will hear the whole story, what problems we had initially and how we developed a system to solve them. My inspiration about this talk came from the so-called hero's journey. But first, who am I? I'm Anton Angelov, a quality assurance architect in progress. I'm a proud owner of automatetheplanet.com, where I share all my ideas about code and tests. Also, I'm a most valuable blogger at this zone and an MVP at Code Project. Before we begin, just let me quickly introduce to you the plan of the talk. First, I'm going to tell you our problems that we had at the beginning through storytelling and analogies about the hero's journey. Then I'm going to present to you the core idea about the 8-level assessment system and what for we use it. After that, I will explain the concept behind each level. The rest of the presentation will be about giving examples how to apply the proposed system in the real world, comparing the different test designs and choose the best one. By test design I mean different methods for writing end-to-end tests rather than boundary value analysis and so on. What classes we use, how we arrange the tests and so forth. The first example will be about the facade design pattern, facade-based tests. I will quickly explain what the facades are and then use the system to evaluate the design. The second one will be about behaviors in tests. We will assess them as well. And lastly, we will talk about spec flow. I will again shortly tell you more about the design and then compare it using the system. In the end, we will sum up everything learned. Intrigued by methodology, author Joseph Campbell studied the myth and made his famous claim that nearly all myths and some other story types share common ideas and format. The different adventures stages are called the hero's journey. There are 12 steps to the hero's journey. And now I'm going to tell you my hero story, or at least one of them. These steps refers to the hero's normal life before the adventure begins. We had over 1000 tests. That ran for over 6 hours on a single machine. Sometimes all of them were green, but sometimes there were problems, so we needed to troubleshoot them over and over again. The hero faces something that makes him begin his adventure. This might be a problem or a challenge he needs to overcome. The biggest problem for us was that we couldn't trust our UI tests. They verified big part of the system, but were so brittle that because they weren't designed in a way that can be easily modified. Small changes in the main workflow caused almost always regression in a random group of tests. Our challenge was to find a better design so that we can refactor them and make them more maintainable, more readable and always green. The hero attempts to refuse the adventure because he is afraid. Before we came up with the system, we tried to patch up the tests and find quick solutions, hoping that this way we can fix the regression problems and simultaneously be able to add new tests. However, our problem here was that for quite some time we didn't have the whole picture. As you will see through the analysis and comparing of the different tests, we achieved much better results. The hero finds someone who can give him advice and ready him for the journey ahead. We had the issues that the developers didn't know what the QAs are doing, and usually the design and architecture of the test was a responsibility of a single man that could not know everything. I think one of the best things that the system gave us was that the final decision for the most appropriate design of the test was the result of a team effort. The hero leaves his ordinary world and crosses his first threshold. My team is using the Scrum Agile methodology. As you may know, in Scrum, at the end of every sprint, there is the so-called retrospective meeting. As a team, we decided that we need to revise our current approach for writing system tests. So my hero journey started. So now it's time to present to you the different levels of the system. Each level represents a characteristic of the tests. As you will see, they are listed in a numbered order, which means that they are ordered by importance. However, I think this order depends highly on the context of your team and the skills of the members. So you can reorder the criteria if you want. Our team is responsible for a complex legacy licensing system. We need to have lots of regression tests and be able to extend and modify them easily. Because of that, the maintainability holds the first spot. Since we have lots of tests, they need to be readable, because sometimes the tests are documentation too. The third one is code complexity index. I will tell you more about it in a little bit, but it basically represents how complex our code is. We want our code to be simple. Also, it is the only true calculated metric. We don't want to reinvent the wheel, so the usability is important. The next one is flexibility. How easy is to learn to write new tests? The learning curve. And the 7 is connected with the maintainability. I will tell you more about it in a little bit. And our last result of comparing is that the simplest design wins if all other criteria are equal. It's not a metric, but rather a principle. For every criterion, there will be a rating assigned. You can find available ratings on the slide, and of course they have a number representation. Here are some pragmatic steps in order to apply it. First, create whole new research development branch. Then, create separate projects to test your new ideas. Do not refactor your existing test framework. Code before you are completely sure which idea is the best for your case. To be able to evaluate effectively and assess the different ideas, it is best to choose a small set of identical tests to implement. Create different folders for each idea. Choose a small set of identical tests to implement each design. If the tests you create are different, how do you expect the assessment to be accurate? Usually we don't refactor differently out of our tests because it costs a lot of times that we usually don't have. Anyway, the system will work for any number of tests. Then, present the design to your team. And lastly, use the provided 8-level evaluation system to assess the different solutions. It is best if a couple of people participate in the process, because some of the points are personally subjective, like what is readable test and which design is more easy to learn. Create a final triage meeting with your whole team and decide which idea to implement based on the results of the assessment. Before we proceed with the examples, how we use the system, I'm going to explain what every criterion means. The official definition by Wikipedia is the following. Maintainability has been defined as the ease with which a software system or component can be modified to correct faults, improve performance, or add attributes or adapt to a changed environment. The key word here is ease. The most important part for me is the troubleshooting. How much time do you need to find out if there is a bug in the functionality that the test is asserting, or it is a problem with the test itself? When there is some issue in the code, you are walking into the box. You are all sweaty, walking and unable to locate it, and debug deeper and deeper and deeper to find out the root cause. I'm sure you have experienced it more than once. This is the maintainability what I mean. Readable code is code that clearly communicates its intention to the reader. Code that's not readable takes longer to understand and increases the likelihood of defects. There is a tendency for some programmers to use comments as a substitute for readable code, or to simply comment for the sake of commenting. I believe test readability means how easy is to find what the test does without the need of huge comments or large test descriptions. I'm sure all of you, at least once in your lifetime, have seen a test name that is 2 rows long. The code complexity index is our custom-made metric. We created a formula for it. It contains 4 important parts that can be calculated with tools such as Microsoft Visual Studio IDE. This is the only metric from the system that is tool calculated. All others are based on the participant's opinion. Depth of inheritance means the deeper the hierarchy, the more difficult it might be to understand where particular methods and fields are. The class coupling is about the good software design dictates that types and methods should have high cohesion and low coupling. High coupling indicates a design that it's difficult to reuse and maintain because of its interdependent on other types. These metrics calculations are available in the development editions of the application, even in the free one, the community edition. The maintainability index calculates an index value between 0 and 100 that represents the relative ease of maintaining the code. A high value means better maintainability. Most of the formulas used to calculate the metric are not public. However, I found an official one on the slide for the maintainability index. I'm not going to decipher it. I want just to emphasize that real mathematics stays behind the metrics. The psychomatic complexity, below you can find the formula, is based on the numbers of decisions in a program. The control flow shows 7 nodes, shapes, and 8 edges, lines. Then using the formula, the psychomatic complexity is 8 minus 7 plus 2 equal to 3. Here are the few images how to calculate the mentioned metrics using Visual Studio. First, you need to select your project and find the Analyze menu item in the context menu and click Run Analysis. After a few seconds, the code metrics results window will show up. There you will find the green Excel icon. Once you click it, you will be able to export the results to an Excel sheet. Since you cannot calculate the metric only for a couple of classes, only for the whole project, to be able to calculate the parameters only for a few chosen classes, you can filter them by full namespace, which is available on the sheet. I could not find any official values published by Microsoft for assessment of this criteria. So I did some research and read blog posts of Microsoft MVPs that suggested a sample assessment system, so I modified it a little bit to fit our needs. You can observe the result in the presented table. We use the table to calculate the rating for the different parts of the formula. By usability I mean how easy is to use the test framework API. How much effort is required to write a new common test leveraging on the existing test API? How much code do you need to write a single simple test? If you use complex design patterns and lots of classes, your test may become really complex. The test writing should be a straightforward process, should bring joy and pleasure to the writer. And my dream is to be able to write tests through 3 to 4 touches of the keyboard. This is something like the test variation of the iPhone. Easy to work, easy to use test framework API, effort to write a new common test, code amount to write a new simple test, and the test writing should be a straightforward process. By flexibility I mean how easy is to add a new step to the existing workflow. If you have 100 tests that use one priority method for the whole process, and the whole process is described there, that means that if you want to support 20 different use cases, you need to have lots of conditions in your code. Usually the conditions make the code more complex and less maintainable. Also, design as previously described will not follow the open-close principle that states that software entities should be open for extension but closed for modification. Every change in this imaginary method can affect all of the tests that use it. Best test frameworks designs should allow you to add new steps quickly without the possibility to affect all other tests. For example, you want to add a new assert for the new tax applied on the last step of the shopping cart. You want to add it just for 2 tests and not affect the other 20. If a new team member joins your team and he needs to read 100 pages long documentation before he is ready to write his first tests, or even worse, if you don't have any documentation at all and you need to spend countless hours teaching new member how to start writing, this means you have a poor test frameworks API learning curve. When the assessment system was designed, most of our tests shared the currently executed test data through a static class. Most of the times, the different components of the design did not need to use the whole information, so we decided to include the principle to our list. For example, if you have a client that have first, last name, email, country and so on, and you have a test for resetting a password, if you pass only the email, everything is okay. But if you need the whole object, this is a problem. Keeping things simple is ironically not simple. It requires abstract thinking, and let me quote Martin Fowler: "Any fool can write code that a computer can understand. Good programmers write code that humans can understand." Think about it for a second. How much code have you seen that was easy to read, that was simple enough to understand? Probably not a lot. This is not a metric as the previous ones, and we don't assign rating for it. We just apply this principle if all other criteria are equal, but usually it's not necessary. This is like an election ballotage, and but as you will see, we are not going to use it in the examples. The sixth step of the hero's journey is the approach step, and setbacks occurs, sometimes causing the hero to try new approach or adopt new idea. We have lots of ideas and approaches, but we need to analyze them well and decide which one is the best. Because of that, now it's time to show you how to use the system in practice. I will use the system to I will use some of the real designs that we evaluated in the past. I will shortly explain the specifics of each one of them, and then I will assign ratings for each level described in our assessment system. Further, I will clarify the reasoning behind my rating decisions. The initial versions of our test framework utilize the facade design pattern. This is the first design that we are going to evaluate through the proposed assessment system. A facade is an object that provides a simplified interface to a larger body of code, such as a class library. It makes the software library easier to use and understand, is more readable, and reduces the dependencies on external or other code. There are not any real drawbacks, as it provides a unified interface to a set of interfaces in a subsystem. However, the biggest problem for us was the size of the facade files. They got enormous, like thousands of lines of code. We had to use regions inside them to separate the different parts of the code. Regions let you specify a block of code that you can expand or collapse when using the outlining feature of the Visual Studio Code Editor. We use a slightly modified version of the pattern. As you can see in the class diagram, the page holds reference to the element map through the map property inherited from the base page class. The page implements a specific interface that defines what actions it should be able to do. The assert methods are implemented as extension methods of the interface of the page. As a result, we can use them directly in the test as normal methods provided by the concrete page. This is the code of our shopping cart facade, responsible for creating purchases. We decided to use the facade design pattern in a little different way. It combines the different pages methods to complete the wizard of the order. If there is a change in the order of the executed actions, I can edit it only here. It will apply to the tests that are using the facade. The different test cases are accomplished through the different parameters passed to the facades methods. These types of facades contain a much less code because most of the logic is held by the pages instead of the facade itself. This is a sample usage of the facade in tests. First, we need to initialize all required parameters. After that, you simply call the main workflows method. Here is the seventh step of the hero's journey. It is all about the hero learns the rules of his new world. He meets friends and comes face to face with foes. The analogy here with the top is that after we came up with some new idea or design, we need to list all the great things about it that can help us, and all the bad stuff, the faults that can harm us during the time. The pros are that the facade hides complex test logic, simplify the test creation, and the workflow changes happen in a single place. The cons are that their files are enormous in size, have huge constructors, the test workflow is not clear directly from the test body. A change in the facade can affect a large number of tests, and finally it's hard for the new people to orient themselves in the large files. The maintainability is very good. The troubleshooting and adding new features to the facade is straightforward. However, the rating is not marked as excellent because you can easily introduce a regression in the existing tests with small changes in the facade. The readability is evaluated as poor. The tests contain much less code compared to all other solutions. However, as you call only a single method from the facade in the tests, it is not clear to the user what this method is doing under the hood. Further, due to their large sizes, the facades are relatively unreadable and it's not easy job to find something inside them. The facade classes have a poor index because they are large in size and they depend on lots of other classes, such as other facades and lots of pages. On the opposite, the test classes are fairly short in size and call only the facade itself. The usability is very good. The writing of new tests is straightforward. The rating is not excellent just because the user has to initialize the test context upfront. The flexibility is very poor. If you change some of the existing workflows, you will affect all existing tests and possibly create regression issues. If you need to create custom workflow, you have to add custom public workflow method, which makes the already large facade even bigger. You cannot change or customize the already constructed workflow on a test level. There are two tricky parts with the approach. First, you should know how to initialize the text context correctly. Secondly, if there are multiple public workflow methods, you should be aware which is the most appropriate to call. The facade has access to the whole test context, which is usually enormous in size. Not all methods need all the information present in the test context. Because of that, the rating is marked as poor. Now it's time to present to you the second design that I'm going to evaluate through the assessment system. I named it behavior-based tests. In general, one behavior executes a page-specific workflow, performs actions and waits for a condition. There are different types of behaviors: actions only, asserts only, combining both, or adding additional pre-post wait conditions such as waiting for page to load or waiting for an element to be visible. On the slide you can find the base class for all behaviors that first execute an action and then wait for something to happen. The concrete implementation of a particular behavior does not have to override all base class methods. If there are post, pre-wait and assert methods available, the class can override only one of them. The behaviors hold private instances of all dependent pages or other services. They are initialized in the behaviors constructor through Unity IOC container. The specific behaviors can accept custom parameters if needed. The behaviors are added as a list to a specific behaviors executor that is responsible for executing them in the appropriate way. If the behavior depends on any data, it is passed to its constructor. The behaviors are readable. Using them, you can see more granularly the different steps from the workflow. If you don't want to perform some of the source mini workflows, you just do not include its behavior in the list. The principle of least knowledge is followed because you pass only the required data to the behaviors constructor. However, a lot of new classes are introduced. The writing of new tests is slower because now you have to initialize all required behaviors. The process of test writing is more error prompt because you can mistake the steps order or assign wrong values to some of the behavior's parameters. The maintainability is marked as excellent. The behaviors are mini workflows for some use cases. If the use case should be changed, it is edited only here. As the behaviors are added only on demand, they are not executed for every case. If you fix one behavior, the change will affect only the tests that are using it. The readability is evaluated is very good. As the names of the behaviors are self-describing, you can guess their use case. Moreover, as you list multiple behaviors to define the bigger workflow, the order of the steps is directly visible to the reader. The behavior classes are small and simple. However, the test classes are more complex because you need to initialize the whole behavior's execution chain. The test framework's API is not so complicated to be used. However, you should know the exact names of the behaviors that you want to specify in the large workflow. Moreover, you should be aware of their correct order. Mistaking the order of some of the steps is possible, and the writing effort is slow because you need to initialize multiple new classes. If you want to skip some of the optional mini workflows, you just don't need to add them to the executor's chain. The same is valid if you have to add some custom mini workflow that is valid only for a small limited amount of use cases. You just need to create the behavior and add it to the list of the behaviors for this particular use case. The learning curve for the test framework's API is average, because the user should know the exact order of the behaviors. Moreover, should be familiar with the correct names of all behaviors and which exact implementations want to call. There might be more than one implementation where it is slightly different. You pass only the required parameters to the concrete behaviors, so the rating is marked as excellent. The next design that we will evaluate through the system is the design where the tests are written using specflow. The specflow uses the Gherkin DSL to describe the behavior of the system using human-readable syntax. It uses the so-called specifications, where the test scenarios are described through Gherkin sentences. On build, the DSL is compiled to MS test tests. Another thing that you have to do is to define binding methods for every sentence used in your scenario, otherwise the test will fail. These bindings are defined in standard C# classes marked with bindings attribute. Each step method is marked with the step attribute containing the step's regex pattern. Inside the steps methods, the page's logic is called. This way, every step defines and executes a small part of the test workflow. With this approach of test writing, the standard MS test class don't exist. They are so-called hooks, classes where a different pre-post execution logic can be defined by a run feature step block or step level. For example, here we start a browser before each test and register only the pages as singletons for the test. After that, we close the browser. SpecFlow supports data-driven tests through data tables. A new test is generated for every row in the table. Keep in mind that I formatted the table manually. The Visual Studio support for Gherkin is not on the needed level. The table will pass something like a list of dynamic objects to our binding method. Here is how we use the SpecFlow parameters table in tests. As I pointed, it creates a dynamic list of objects that we can iterate through them. So, the pros. The test scenarios are readable. The initializations are visible in the tests as they are described as a couple of sentences. The scenarios describe a specific feature and there is description. Multiple scenarios can be generated through examples data table. This way, similar tests are generated where only the input data is different. The differences are more visible to the reader. The different arranged active search parts of the tests are more clear to the user. The cons are that existing MS test execution workflow cannot be used, should be rewritten with SpecFlow hooks. The tags used in the feature files are plain text. Cannot use constants inside the feature files, which means that all input data is hard-coded and cannot be reused. Additional binding files should be present in order SpecFlow to be able to work. Additional NuGets packages and Visual Studio extensions should be installed, and test names generated from the examples table are not readable. Everything mentioned for the behaviors is applicable for this approach too. However, the rating is decreased because the additional binding files exist. Moreover, the user cannot use existing tags and constants in the feature files, which leads to hard-coded data and copy-paste development. The main advantage of SpecFlow is readability. All steps are described in human-readable syntax via the Gherkin DSL. Even the base initialize methods are described with a couple of sentences, which makes them more meaningful to the user. The code complexity index here is not entirely accurate because Visual Studio doesn't support the calculation of code metrics for Gherkin files. The index for binding classes is marked as very good, probably because there are not any base classes. However, they depend on multiple classes such as pages and behaviors or facades. I think you will agree with me that if we could calculate the metric for the Gherkin files, they weren't going to be very good. Because of that, I decreased the overall rating with 1, and it's only marked as good, or 3. The rating for this parameter is calculated as very poor, because there are a lot of new classes that should be created before the user can use any steps in his test, assuming that he/she is writing a new test from scratch for a new feature. The SpecFlow integration with Visual Studio is poor, and the suggested steps while writing are not very helpful. I refer to the IntelliSense. It is a challenge if you need to define a couple of actions with common starting words. You should define different overridden methods in the binding classes plus use custom regex patterns. If you use examples table to generate tests, you should format it manually if you want to be readable. The rating is only good because in order the SpecFlows API to support additional steps, you need to create wrapper methods in the bindings classes with custom regex expressions. I guess it will be harder to write new tests compared to the approach with using only page objects, especially if there isn't existing tests using the SpecFlow sentences steps. You pass only the required parameters to the concrete binding methods, so the rating is marked as excellent. The 8th step from the hero journey is called ordeal, and the hero experiences a major obstacle. Before the usage of the system, this CAD was made. I struggled with the decision which of my ideas to apply next. I was always wondering, is it going to help us or not? But through the aid of the assessment system, we have the final results table, and it can give us all of the answers that we need to make our final decision. Without further ado, here are the final results. Here you can find the final assessment results. Through the usage of our system, we were able to find the definite winner, the behavior-based test approach. It outrun the facades in all aspects. Also, as pointed at the beginning, we didn't need the help of the last point of the system, the keep it simple principle, KISS. The 9th step from the hero's journey is the reward. After surviving that, the hero earns his reward or accomplishes his goal. After lots of research, reading and mind struggling, we came up with the best design between these three. Now for our end-to-end tests we are using the behavior-based tests. The next step is called road back. The hero begins his journey back to his ordinary world. We had this problem before, that we didn't have information why the system is designed as is. Usually the people that made the decisions were not part of the team or the company anymore. What I mean here is that when we choose the preferred writing approach to our system, is always good to write something like a documentation or blog post in the Teams portal or wiki, so that if you in the future the approach needs to be revised, we can check fast our previous considerations why we choose it. One of the most important steps from the hero's journey is the 11th one. The hero faces a final test where everything is at stake and he must use everything he has learned. This is his final and most dangerous encounter with death. I think this step refers to the moment where you apply the chosen design and see if it really helps. I think in our case the tests became much more stable. In order to believe me, I made a little research. As you can observe from the chart, at the beginning we had more severe bugs compared to the end of the period. Somewhere in the middle, after sprint 19th, we refactored our tests. These are the bugs found after the deployment of our applications. The bugs found on developers' machines are not locked, and most of the times our developers run some of the appropriate system tests along with the unit and integration tests on their machines before checking. At the beginning they didn't trust our tests because most of the times when the tests failed, the problems were connected with regression in the tests. After we used our system and refactored the tests to use behaviors, our tests became much more stable. Now our tests tend to have less regression because the changes are scoped, and I can test and fix all bugs before checking. I want to point out that we have CI and nightly runs, and these tests are run before that. Here is the last step of the hero's journey. The hero brings his knowledge, or the elixir, back to the ordinary world, and he starts to help others. It was a long journey. I told you what problems we had at the beginning. Not trustful tests. Then I told you the story behind the assessment system. We went through what each point means. Then I showed you the system in action, evaluating the facades, behavior states, and the specflow tests. It is hard to teach you to create good test frameworks design, but at least you now have a powerful tool to evaluate your test frameworks design quality. Here you can find a few resources that help me to learn more about design patterns. The first two bullets are the books that help me to extend my knowledge of design principle and patterns. The next bullets are online resources that you can use to expand your know-how. You can find more information in the biggest programming sites such as Code Project or DZone. They have dedicated design pattern sections. Further, you can check my site automatetheplanet.com, where I write about design patterns in relation to automation testing. And finally, you can follow more adept developers in Twitter and ask them to help you. Thank you.